So this is lesson 2.4 and 2.5, using sine and cosine ratios to calculate angles and lengths. Right here we see a construct your understanding. What this means is I'd like you to pause and do this on your own. Okay, we'll talk about it for a second right now though. A says examine the nested right triangles below. We know that a right triangle is any triangle with a 90-degree section. That makes it a right triangle. So here you see all of these squares that represent 90 degrees, and we know that they're right triangles. The reason it says nested is they all share this angle A. So if you take a look, there's 1, 2, 3, 4 different triangles here. So I want you to take a look at this, complete these questions and the table that is right here. Decide how the ratios compare. Remember, a ratio is something compared with something else. And then take a look at the next page. In a right triangle, the ratios that relate each leg to the hypotenuse depend only on the measurement of the acute angle. Remember that acute angles are any angle that's less than 90 degrees. Anything that's smaller than 90 degrees. Okay? And not on the size of the triangle. These ratios are called the sine ratio and the cosine ratio. The primary trigonomic ratios, so there are 3 of them. We have the tangent ratio, which we've already talked about, sine ratio, and the cosine ratio. There are only 3. When we take a look at our triangle on the right here, we have a few things that we need to label. We know that this side that's long, it's usually the longest side. In fact, it's always the longest side on a triangle. It's directly opposite the 90 degrees here. We know that that is our hypotenuse. Okay? If we call this here our theta, our angle, because this is the acute angle that we're going to take a look at today, the side just beside it that's not the hypotenuse is the adjacent, and the side opposite it is the opposite. Okay? Let's take a look at the tangent ratio first. So the tangent of an angle A, which we have on our diagram already, is the ratio of the length opposite of angle A over the length adjacent to angle A. Okay? So the way that we write this, often you'll see TOA. You might recognize this from the last set of notes. TOA. So T is the tangent, O is opposite, A is adjacent. So it's a way to remember this exact sentence. The sine ratio. The sine of an angle A is the ratio of the length opposite angle A, we're still talking about angle A, over the length of the hypotenuse. Okay. Let's take a look at the cosine ratio. oh, sorry. The way to remember sine is S-O-H. So we have TOA, SO, and the last one, cosine ratio. The cosine of angle A is the ratio of the length adjacent angle A over the length of the hypotenuse. Oh, I should spell that correctly. Hypotenuse. Hypotenuse. Okay, so in short, in this box here, sine of A equals opposite over hypotenuse. Cosine of A is adjacent over hypotenuse. Tan of A is opposite over adjacent. Sorry, that's supposed to be an A. So if we to recall the trigonomic ratios quickly, remember the acronym. Acronym just means a set of letters that's the first from each word. So we have S for sine, O for opposite, H for hypotenuse. C for cosine, A for adjacent, H for hypotenuse. T for tangent, O for opposite, A for adjacent. So this is for sine, this is for cosine, and this is for tangent. So when we take a look, you can use your scientific calculator to determine the measure of an angle. When you know its sine, use sine to the -1. This is the same as sine inverse. If you know when you're using cosine, you can use cosine to the -1, which is the same as cosine inverse.